Hello, welcome to our lesson today on loading of beams and columns for analysis and design. My name is Engineer Dr. Egidion E. Ambrose from the Department of Civil Engineering at Akwa Ibom State University, Akwa Ibom State, Nigeria. So we will be going through load transfer on structures. And in most building and other civil engineering structures, now slab are the first line vertical supporting element. Now this means that the dead load and all the live load on such structures are usually carried directly by the slab. For instance, if you're in the building, you're most likely going to be resting on the slab, on the floor slab. All your load, your bed, if it is residential, the table, if it is office, all of them are going to be resting on the slab. And the dead load includes things like the self-weight of the slab and other permanent actions, which include the weight of finishing, the weight of the partitions, and maybe the weight of ceiling, assuming the ceiling is attached to this floor slab. And many of the slabs in our usual building designs, they are supported by grid beams. That means the beams at the edges of the slab. And therefore the design load of the slab, that is all the permanent and the variable action on each slab, is being transferred to the supporting beam. So if you have a slab that is supported, a rectangular slab that is supported by all the beams at the edges, that means the load of the slab will be transferred to the four beams at the four edge of that slab. And so load transferred to each beam is include its self-weight and then transferred to the supporting columns, which in turn is transferred to the foundation. What does that mean is that when the load from the slab is transferred to the supporting beams, for each of the beams, the load transferred from the slab and the self-weight of the beam will be transferred to the column that are supporting the beams, and the column will in turn transfer the load to structures. And that is how load is transferred in structures from the slab down to the foundation. So before we do the load transfer, first of all, let's look at the design load. So the design load are usually calculated by summing all the permanent actions and all the variable actions and multiplying each of them by their respective factor of safety. For design using Euro codes, the design load is calculated using this expression in equation 1, where N is the design load and GK is the total permanent actions, and QK represent the total variable action or life load, if you may call it. Remember, the permanent action can also be called dead load. Now this 1.35 is a factor of safety for permanent action, while 1.5 is a factor of safety for variable action. So with all this information, you can calculate the design load on a slab. Now the distribution of slab load to the supporting beams is usually based on the aspect ratio of the slab, and we are going into that properly now. Now aspect ratio is a ratio of the long span to the short span of a slab. For instance, if you have this slab, this is LY, which is the long span, and this other side is LX, which is the short span. The ratio of the ratio of LY to LX is what is called aspect ratio. Now let's look at the first case, case 1, one-way spanning slab. A slab is said to be one-way spanning if the aspect ratio is greater than 2. So when you're doing Ly over Lx, if it is greater than 2, like in this case, so that slab is called a one-way spanning slab. Now for such slabs, as presented in this figure 1, 1a, it is assumed that the load is carried equally by the two long beams, that is beam A and B. That means that this load on this slab is carried by the two long beams, that is beam A and beam B at this long edge. It is assumed that the beams at the short span, that is beam C and beam D, are not carrying any load. That is theoretical. So how do we calculate the load, distribute the load of the slab to the beams? Let's go. Now half of the slab area is supported by each long beam as shown in this figure 1b. So half of the slab area, for like half here. Remember this slab is divided into two now. Half, this other one is carried by beam A. This other one is carried by beam B. That is what it means. So now the slab's area supported by each beam is called tributary area. So for this one, this is a tributary area supported by beam A. This is a tributary area supported by beam B. So the slab load on each long beam is determined by multiplying its tributary area by the design load. So then this is the one tributary area carried by this long beam. So to get the load on this beam, we multiply this area by the design load, and this is what we do. So this is a rectangle, and what is the area of a rectangle? Is length times breadth. So that is how we come here. What is the length of the beam, which is this span? It is Ly. What is the width? The width is Lx over 2. So that is why we have Ly multiplied by Lx over 2 gives us the area. But when we multiply the area by N, which is the design load, it gives us the load of the slab that is carried by this beam. By doing this, so the slab load on each long beam is obtained as a concentrated load. When you do this calculation, you get the load as a concentrated load. And then the self-weight of the beam will then be computed and added to this concentrated load because the beam is also carrying its own weight. So when you add the weight of the beam plus the weight from the slab, you have the total concentrated load carried by the beam. Now the total concentrated load is usually divided by the length of the beam to present it as a uniformly distributed loaded beam. So when you do that, the concentrated load will become a uniformly distributed load, that is a UDL. Let's look at case 2. Case 2 is a square slab. Now a square slab is a two-way spanning slab with an aspect ratio of 1. That means Lx is equal to Ly. Now for such slab, the slab load is divided equally to the 4 supporting beams such that the tributary area of each supporting beam is as shown in figure 2a. So this is figure 2a. You can see there are 4 beams carrying this square, supporting this square slab. Beam A, beam B, beam C, beam D. Now the tributary area is such that the slab is divided into 3 equal triangles. So this tributary area is carried by this beam A, this tributary area carried by this beam B, this one by beam C, this one by beam D, and it's very simple. So the slab load on each beam is computed by multiplying its tributary area by the designed load. Notice that because they are divided equally, these angles are 45 degrees. The angle of these divided lines are all 45 degrees. And so to calculate the load, for instance, if you look at this is one of the beam carrying the slab, and the slab is a rectangle, a triangular tributary area. And what is the area of a triangle? Half base times height. What is the base? The base is Ly. What is the height? The height is Lx over 2. And that is why we have here half base. That means Ly over 2 is half base. The height is Lx over 2. When you multiply that by the divine load N, you have the slab load carried by that beam. Again, you calculate the self-weight of the beam and you add to that slab load and then divide it by this length Ly. It becomes a uniformly distributed load. Let's look at case 3. Case 3 is a situation where you have a rectangular slab. And now the aspect ratio of a rectangular slab is usually greater than 1 and less than or equal to 2. So you can have, this is a rectangular slab. Now for such slab, the slab load is distributed to the 4 supporting beam as shown in figure 3a. If you look at figure 3a, this is a rectangular slab. The load is divided by the 4 supporting beams in this manner. Notice that this beam A and beam B are the beam on the long span, that is the LY, while beam C and beam D are the beam on the short span, that is the LX direction. So for the short span beam, they are carrying triangular tributary area, and the triangle is such that this line is 45 degrees. You can see this is 45 degrees, this is 45 degrees. This one will also automatically be 45 degrees. But you can see the way this triangle is carved out so that you have 45 degrees, you have 45 degrees. And this other thing happens like that. By the time you finish, you will have, this one will be a trapezoidal tributary area. So the beams on the short span are carrying triangular tributary area, while the beams on the long span are carrying what? Trapezoidal tributary areas. Now each of the two short beams C and B will support this triangular tributary area of the slab, which I have said. Each of the two long span beam will be supporting trapezoidal tributary area as shown. So if you can bring out the area, the tributary area of one of the long span beam, this is what you have. This is a trapezoidal tributary area. So that is how it is. So all you just do is to calculate the area of this and multiply by the design load. So now let's look at the case of load transfer from beams to column. Now we know how load are transferred from slab to beam. Let's look at how loads are transferred from beams to column. So load from beams within a span are usually distributed to the supporting columns. For the phase 4, the floor plan in figure 4, this is figure 4, and this is a floor plan of a building. You can see that column A is supporting two beams, that is beam AB and beam AE. Hence, half of the load from each of these beams will be transferred to it. So half of the load from beam AB will be carried by column A, while half will be carried by column B. When you come to beam AE, half will be carried by column A, and half of that beam load will be carried by column E. And that is how. Now, similar thing will happen at the other three corner columns. That is this column, this column, this column, this column. A similar thing. Now, columns B, C, G, H, and J. Column B, C, G, H, and J. Those are middle columns. They will be carrying loads from three beams. Column B will be carrying half of the load from beam AB, half of the load from beam BF, and half of the load from beam BC. The same thing, column C will be carrying half of the load from BC, half of the load from CD, half of the load from CG. And column G will be carrying half of the load from GF, half of the load from GC, half of the load from GH, and so on. Now, finally, column F will support load from 4 beams, because column F, look at, is supporting half of the load from EF, half of the load from FJ, half of the load from FG, and half of the load from BF. And that is how you can. So once you are able to find the load on the beams, once able to define the loads on the beam, you can therefore divide the load of each of the beams to the supporting columns. That is how it is done. In our next video, we are going to solve example to show you how it is done practically. Thank you for watching this video. Remain blessed and don't forget to subscribe to this channel so that any video, any new lessons coming, you will be getting them just when it lands. Like I said, subscribe to this channel. Remain blessed. See you in the next lesson. Thank you.